because it's got the most land. And so if you just look at a planet and you're holding the Earth, knowing that heat in the atmosphere comes from the surface of our land, well, the biggest input of energy, the strongest impact on the atmosphere is where there's the most land, because that's a lot of heat. Now, if we had a different atmosphere, that might just make one big ass circle. But because of the size of our atmosphere, how much water there is, you basically give up all your heat within 30 degrees. And so this process is decided by the size of our planet, how much heat is made, how much heat is lost. Yeah?
How would you describe which direction they're going? Would we say how would we describe which way they're going?
Well, clockwise and counterclockwise when seen from the side.
Or you could say north and south.
North and south.
Okay. Just making sure they don't want us to be doing some.
No, I don't think so.
Okay, cool.
Now, here comes an amazing trick that explains the whole planet. And in order to make this really good, Liam, I need you to hop up on the table that has the computer and move all those papers off it. Everybody look at me, try not to focus on Liam's awesomeness. Watch this. I don't know, we're about to find out. Hey, it held. Okay, everybody look over here. Look. Where hot air rises, you get a bunch of rain, right? Hot air rises, you get a bunch of rain. You all remember that? If all the water was used up here, is this going to be hot or cold?
Cold.
Is it going to be wet or dry?
Dry.
So we have hot, wet air going up and cool, dry air coming down, right? So this is going to be an area of cool, dry. This is cool, dry. This is hot, wet, because there's air coming up, right? You understand what I'm saying?
Need these down too?
Yeah. Get to work. Here we have cold, dry. Here we have hot, wet. This is going to be cool and dry.
It alternates between hot, wet, cool, dry, hot.
It does every 30 seconds. Every 30 degrees. Now everybody stand up on your desks. Quick, go, hurry, we got stuff to do, hurry. Liam, get this over with. Everybody stand up on your desks.
Someone's gonna fall.
I hope so. And look at that poster. There's your bands.
That's what this was for?
What's the problem?
I just started.
That's a good poster. But your time is free. Look, a band of wet at 0, a band of dry at 30, and there's not a lot of land, but at 30 south it's dry, dry, dry. So dry, wet, and the driest deserts are the North and South Pole. Isn't that fascinating? Everybody sit again. Liam, I don't know where to put those posters, but I'll have to do that in all the other period sentences.
You feeling huge?
Put it all back up.
Yeah, you should.
You want it all back up?
Nah, I might not have it to you in this period.
Oh yeah, and then yeah.
Put it back up.
Did you have to do that last period? There was no one here. Yeah. There, bottom's on.
And by the way, I've got one more really cool trick for you. That's cool though, right? Why we have bands of vegetation and bands of desert? The atmosphere is different in different places.
Yay.
Hey. One last thing. I'm going to do my best to sketch a really messed up planet, and you don't get to judge me.
That's bold of you to assume that we
That
will.
line's not straight.
At the equator,
This is very
we've got some Africa,
A little bit of that.
Oh, that's beautiful right there.
And we've got
Honestly, that's not my
Yeah, that's not even bad.
a little bit of whatever that area is that nobody cares about, where all the people don't matter. And then we've got like a little thingamabobber with like a whatchamajiggy and like a thing, and then some like nuggets. And then we go up over here. There's a lot of white people. And I'm afraid, don't leave my children unattended up here. Polar bears. And there's the Haliushins. We do a little scoop, and then somehow the west coast of the United States has got way too big. And then, is this like, is that Portugal? Spain?
That's Spain.
I'm pretty sure
Yes.
it's Spain and France.
That- what? I can't even.
Poland,
What?
and then Czechoslovakia, and goes like that, and then there's that one weird island that looks kind of like a scrotum. Four weird islands. I don't know how many different countries that is.
4.
There's a big chunk of ice.
The progression
All right.
Start again.
You said you wouldn't. I said you wouldn't judge me. So
And
We
here's,
never
would.
made any promises.
there's 30.
You just have a map of the world somewhere.
There's 60. I know, but I gotta draw on this one. All right. Now, if you're a human standing right there, the wind goes from what direction to what direction?
From north to south.
Thank
Does
you.
that say ho?
So
No, it's a sideways stick figure.
from 30 to 0, from 30 to 0, the wind goes north to south. Do we agree?
Yeah.
Here's why that matters. I need a volunteer, please. Let's go, volunteer, hurry, come up here. Volunteer, hurry!
Actually,
Let's go, volunteer. Oh, can I get a different volunteer? Stand right there. No, right there. Okay. Anybody know which way the planet rotates?
that way.
Good job, yeah, because who sees the sun first? New York City sees the sunrise? So if Luke is my son, then New York is going to be like, good morning, and then they're going to get into the dark when Santa Barbara still sees it, right? And we see the sunset after New York sees the sunset, so the Earth rotates this way. Everybody got that? So, butt face will represent the rotation of the Earth by dragging a sheet of paper, and I will represent the wind. I will represent the wind by dragging my pen. I'm going to just trace that exact arrow, and she is going to slide the planet underneath my pen. Everybody got that? Practice run. Put your fingers right here. Just right there. Now step over that way, and ready, set, drag. Yeah, that would work. You got your practice run done?
Yeah.
Is that good for you? You feel like you can do that again?
Yeah.
Okay, let me find the arrow. Hold on. So children, look, I see the arrow starts right there, and I see that the arrow ends right here. Ready, set, rotate the Earth now. Thank you. You may leave. You can you can see where my pen came off the paper, right? I kind of missed it by a fraction of an inch. Surface winds would go like this, but our planet isn't sitting still. Our planet is rotating. So on a rotating planet, when you apply a rotation underneath to those surface winds, you get circular currents, like that. Those are much stronger than the little bits of water in the small parts of the planet. Look how much water is from 30 to 0 and how little is up there. So these ones just get powered by all this water moving around. I'm almost done, but check this out. You're going to need these also. You get clockwise and counterclockwise rotation in the north and south hemispheres. There comes the Alaska, bringing the Shaka to Santa Barbara. Warm water hitting India.
We just never hear about Asia.
What Asia? Anyway. What even is Asia?
We got emancipated.
Here's the reason I do this, and it's kind of important. You sometimes do need to remember which way these circles go. This explains how the wind moves, and the wind pushes the water. Shh. This is how the wind moves, and the wind pushes the water. You may want to spend a second, don't worry about the shapes of your countries. You'll get the circles going the right directions. And if you don't mind a quick little political comment, I can't believe we celebrate somebody hopping on a boat and quote-unquote discovering the Americas. If you're from this part of the world, trash hits the coast all the time from Europe. Empty sailboats discover the Americas sometimes. If you could survive on an aluminum dinghy, you could discover the Americas. Just push out from Portugal and then just let the ocean do its thing, and maybe we'll give you a holiday and you can claim a continent.
That's Thanksgiving. No, but I couldn't tell if it was Thanksgiving or Columbus Day.
There is a Columbus Day. In some places. I digress. Hey, so everybody knows why our planet has the cool circular ocean and air movement? By the way, I'm Italian. It was kind of bold, I guess, for Columbus to get on a boat and try to discover a place he didn't know. But I don't know, man. I'm not that impressed.
I feel like I could just walk into my neighbor's house and say that I discovered it.
Yeah, that's what I do on Columbus Day. Yeah. I go, hey Chad, this is my house now, celebrating Columbus Day. And Chad goes, get out. I'm like, all right, Chad.
Listening for my grandparents to like.
Such a Chad.
Chad and Lisa, not at all political. Chad and Lisa are not political.
Wait, Chad's your dad's name? I was thinking.
Oh my god. Like.
One more thing before, one more thing. Before the bell, I got one more. Which study goal is greenhouse effect?
19.
19?
That's not in this.
Wherever it is, please look up.
It's 19. It's number 19.
Good. I'm sorry, I know you guys want to talk, but I want to finish. Hold on. Yeah, I'm pretty much good to do this one. I need to add one more word. I need to add one more word and one more study goal before we finish today. We've got about 10 minutes, right? Am I mistaken? We go until 10:02?
10 exactly.
10:01? We got 9 minutes. Watch this. Sunlight can do one of two things when it meets our planet. It can be reflected or it can be absorbed. In case anybody's curious, you get a little bit of reflection just because of glare in the outer atmosphere. You saw that in the video I showed you. You get a little bit of reflection because clouds are shiny because they have ice in them and ice is shiny. Maybe you know about snowboarding and sunburn and getting sunburn up your nose and stuff. People who travel across snow get snowblind because the reflection of sunlight, it's like looking into the sun, right? Snowblind. So the ice in the clouds reflects. And of course, the surface of the earth sometimes is shiny. Like right now, if I look right there, that's kind of blinding. That's pretty bright. That's called albedo. This is the goal number 18.
Yeah.
Albedo is shininess. Like ice and snow have a high albedo because they're very shininess. Albedo means reflectivity or shininess, like a mirror has a high albedo. A black sweater has 0 albedo. Ice and snow have the most albedo. Water has high albedo. So the ocean is kind of shiny, so it reflects some sunlight. Everything else is absorbed, and energy neither made nor lost, it just changes form. So anything that absorbs light will give off heat. If you're wearing a black t-shirt, you know what I'm talking about. So reflectivity, some of it in the clouds, some of it on land. Everything else is made into heat. Please look up. If the planet was more shiny, we'd be colder. If the planet was wearing a whole Earth-wide black sweater, we'd be hotter.
So to stop climate change, we should just cover the entire Earth in mirrors.
And people have done the math, and there's a lot of ideas about how to combat climate change, and some people have said we should explode bazillions of silver something bombs in the upper atmosphere, which make little flecks of reflective ash. People have said that we should make a ring like Saturn of space trash mirrors around the Earth, but gravity, that's a bad plan, falling glass. Somebody did the math, and if you take the 10 largest cities in the world and you paint all the roads and roofs white, you would reverse 1 year of climate change. So every year, if we got 10 cities and painted them white, we could eventually catch up in like 75 years with where we were 75 years ago.
And that'd be so aesthetically pleasing.
I don't know how good it would be. The problem is making all that paint would cost a ton of climate change. I don't know my own strength.
Takes over chair. Can't kick it.
But the shiny things in the upper atmosphere wouldn't help.
Probably not. Too difficult to get in there.
Wouldn't we breathe the ash in because of gravity?
Yeah. All these plans to mess with the planet have really significant downsides. That's why you shouldn't mess with the planet! Okay.
Well, we already have, so.
And that's actually the best argument there is. Like, well, we're already doing an experiment. Let's just change the experiment. I got one last thing to point out, and then we're done. There's something really special about our planet, that arrow.
What study goal is this? Still 18?
We're like shifting. You'll see I'm making the transition between leading up to the atmosphere intro, greenhouse, and climate change. Don't forget to set your clocks back on Sunday.
No.
So stupid. I hate that.
Oh, hey, wait, never mind. I don't care what you think. Okay, watch this. There's this funny thing that some gases do. The funny thing that gases sometimes do is like H2O, for example, or CO2. Some gases are stable, but when you heat them up, they destabilize. And eventually, those bonds between the atoms come back together and they give away the heat. That's called greenhouse gases. We'll talk a lot more about greenhouse gases later. There's a whole list. There's like a study goal I gotta do about greenhouse gases. But what makes them greenhouse gases, watch me, is heat makes them wobble, and eventually they stabilize and give away that energy again. We've known about this since before photography. This was already discovered, like, I don't know, 200 years ago, and it was tested on by this dude that had a neck beard. And he had to make his own apparatus because there was no commercial glass supply, so he made it all out of metal. Like, greenhouse gases have been well known and studied since, like, before Darwin, but this guy actually knew Darwin.
Would you ever get a neck beard? Like,
I kind of have a neck beard.
no,
It's
but
just blended
only a
into.
neck
Nah, it's too much maintenance.
We literally
The-
already have them.
The one thing I want to point out, our planet would, quiet, would be hotter if we didn't have an atmosphere, because we wouldn't reflect so much. And then it would also cool off quickly because we wouldn't keep our heat if we didn't have an atmosphere.
Like Mars.
Like Mars. And so our atmosphere does both, cools us down a little bit by reflecting stuff, and keeps us warm by trapping some of the heat. Like on a cold night, if you're in a sleeping bag, you stay warm. Climate change is we're just adding those gases that have that property that they absorb heat and then re-release that heat. Everybody got that? We have no more video tape.
What are you planning on doing with your